Hello everyone, my name is Deniz and this is the PHYS211 project video. The name of the project was an attempt on observing the Faraday effect and birefringent nature of sugar. So let's start with the first part, which is observing the Faraday effect. As you can see in the figure, we have a linearly polarized light coming towards a magnetic field, and this magnetic field causes the light to rotate a little bit, and you can see that the light exits the magnetic field with a different polarization. This is the Faraday effect, and this is the equation we can use here. This is the rotation angle. This V is a constant called Worded constant. B is the magnetic flux density, and D is the length of this magnetic field. This constant is important because it depends on the medium in which the light travels through. It can be air, it can be water, it can be some types of glass, etc. So now let me explain the setup a little bit. Here is the laser source, and a polarizing filter is placed right in front of the laser source. Here is the solenoid coil, and inside the coil there is a glass which acts as the medium in which the light travels. And at the end of the coil we have a light sensor, and between the light sensor and the coil there is another filter. This second filter is placed such that it allows the same polarization as the first filter, so that we can eliminate a fraction of the rotated light, causing the sensor to react to this decrease in light intensity. This is one of the early trials. Actually, we have tried different alignments with different glass rods and different types of solenoid coils, but unfortunately we have failed to make an observation. But still, I want to talk about the attempts a little bit more. So first thing I want to talk about is that choosing a suitable glass rod for this kind of experiment. Since we are making a laser travel through the glass rod should be clear enough so that it does not make the light scatter a lot. One way to figure out whether the glass rod is clear enough or not is that you take the glass rod like this, you write something on the back of it, and you look from the top. And if you can see the writing at the back of it from looking from the top, that's a great indication of the glass is clear and it will not mess up with the polarization of the light. And the second thing is, if you remember the formula I have shown earlier, this glass should have a high Worded constant value, or one should have a really strong magnetic field source to observe this Faraday effect. But however, we didn't have either of them, so we couldn't achieve any observation. Okay, now we can continue with the second part, which is birefringence of sugar. So birefringent materials have different refractive indices for different polarizations. So let's say we have a linearly polarized light like this. We can divide it into two as right and left circularly polarized lights. As you can see, we can achieve this equation here. So after getting this equation, we can say that the water sugar solution that we will be preparing will have different refractive indices for this first part and the second part. So after exiting the solution, this part and this part will have a phase difference between them. So what we will have is another linearly polarized light, but with a different angle. So this first light and the final light we have will have an angle between them. This is the equation we can use here. This is the angle between them, the rotation angle. This is the concentration of the water sugar solution. And this is the specific rotation, which changes from material to material. And this is the value of it for sucrose, which is what we are using. And this is the length of the solution in which the light travels through. Now let me talk about the setup quickly. So here we have the light source, and we are sending linearly polarized light into the solution. After the solution we have this thing, I will be explaining this, and finally we have a screen at the back. So this thing is simply a polarizing filter which can be rotated. So we have taped this filter in front, and this black cylinder can be rotated. So we did take our measurements thanks to this. How did we take the measurements? So first we did this experiment without any sugar in the water, and we rotated this filter such that we don't see any light on the screen. Then adding sugar made the light to rotate, so that we started to see a light on the screen. So again we rotated this filter such that we didn't see any light. So you can see the marks on this thing actually, and those are the marks we took our measurements from. So we know the radius of the cylinder, and we can measure the distance between these marks. That way we can easily figure out the rotation angle. Here are the results. So we have this equation as I mentioned earlier. So when we put in the constant values we have for this case, we get this theoretical relation between the rotation angle and the mass of the sugar in the water. As you can see, this is a linear dependence, and our experimental data actually matches quite well with the theoretical values up to a certain point, and after this there is a difference between them. We think that this difference has occurred because as we add more sugar to the water, it becomes harder and slower for the sugar to dissolve in the water. So we think that we probably didn't wait long enough, or we couldn't mix it properly up to this point. So that would explain why our experimental data stayed roughly constant, because the amount of sugar dissolved in the water didn't really change, whereas the theoretical values continue to increase. So in the future, the same experiment can be tried with more time spent on mixing the sugar in the water properly. That's the most probable case why this error happened. That was the Physics 211 project. Thank you for watching. See you in future projects.